Let's conclude this section by recapping some of the basics of TDD. Like, let's go back and look at the big picture of what all we did. Remember that where we started is we were adding a new feature. We sort of started to write the first few lines of a cucumber scenario, and we're trying to get one line to pass, which is the one that says, when I submit the form with certain search terms on it. And to do that, we started with a failing cucumber step because we have no code. And then we identified a few specific behaviors that the controller method that receives the form is going to have to do. Each one of those behaviors became its own little test case. They're grouped together in a describe because they're related. They're all testing the same controller method, but they're testing 3 different things about it. And in testing each thing, we're isolating, we're using doubles or we're using other kinds of seams to essentially get out of the way everything that doesn't have to do with the one thing that's being tested, right? This is the thing that, to learn good test writing is to learn how to get all those things out of the way. And by the way, this is where the insight comes from of why TDD as a practice makes your code better. If you find yourself, and if you try to cheat it and you write a controller method first, and now you say, okay, well, now I'll go back and write the test for it. Nobody will know that I didn't write the test first. And what you might find is that there are so many dependencies in there that you end up having to do doubles and seams for everything. In order to have one line of test, you've got to have like 5 lines setting up preconditions and setting up doubles. And when that happens, it is sending you a message. It's saying your code is not well factored, it's not modular, because it's so hard to isolate those behaviors. That is trying to tell you something. So this is the real reason that I advocate for doing TDD, is that when you think of that stuff in advance, because you're thinking about how you're going to write the code, it makes it easier to test because now it's very clear what the dependencies are and what you have to stub out. We haven't discussed it yet, but sometimes there's a set of preconditions that have to be set up that are common to a bunch of test cases. So for example, I might have, to continue the idea of using a controller action, I might have a controller action where there's 3 or 4 different behaviors I want to test, but the same preconditions apply to all of them. An example of that might be this controller method only runs when the user is properly logged in. So every one of those 3 or 4 tests is going to have to first make sure the state of the world is like somebody is logged in. Maybe that's like tweaking a key in the session. Maybe it's something else. But if multiple test cases have the preconditions in common, you can set them up in what's called a before block, and it will run before every one of the tests that it has in common within that describe. So that's why describe is useful. It sort of groups a bunch of tests together, not only because they're related in what they're testing, but because they may share a common set of preconditions that have to be set up for any of them. And then in actually writing the specs, the most important thing is that each spec is really just testing a single behavior, so that when a spec fails, there's only one reason it can fail, and you know exactly where you should go hunting for the bug. Use seams as needed to isolate that behavior. Use things like allow to receive to control the behavior of a method that doesn't exist or of a method that does exist. This part is a little counterintuitive, but to repeat, even if we're now at the point in development where we have created that movie method that calls out to the API, in our tests, we're still going to use allow to receive and expect to receive. Because if somebody modifies that method later and introduces a bug, we don't want that bug to essentially contaminate the way that our tests are running here. Now, there's a flip side to that, which is, let's say that movie find in TMDB changes in the way that the caller API is handled. The kind of thing it returns is different, for example. Our test should be modified to take account of that difference. And so the sort of cautionary tale about writing specs that are isolating all these different control flows is that you really need to be in sync with the rest of the project about what the real method does. So your test is always going to fake out the method because you need to isolate your test from the method's implementation. But you have to make sure you're faking it out in a way that looks like the real thing. And so if the real thing changes, it's up to you to know that that's going to affect how your test runs. You've now got to change the thing that your double returns so that it looks like what the real method would return. And then what type of expectation will check the behavior? What's the thing you're really testing, right? In our case, when we said, does the controller render the correct view? Like, is the view going to make sense? Well, we can check if the correct template was chosen for rendering, and we can check whether the correct information in the assigned instance variables is being made available to that template. We should not be checking what the template looks like after rendering, because the job of taking the template and the variables and smashing them together, that is outside the scope of the test that we were writing. So think very carefully about what's the specific thing that you're asserting, and then go look in the documentation to say, what matchers are available that will help me assert that very specific behavior? Write the test and make sure it fails for the right reason. So in our case, the reason it was failing is we said the controller method should do X. The controller method specifically did not do X. And so then we went back and added code, and now it does X. That's good. That's the cycle. However, if it fails for a reason like the controller method didn't even get called because the test relies on the user to be logged in, but you didn't set up your preconditions to make it look that way, right? That's a test failure that doesn't give you information. It just says you didn't write your test correctly. So once your test is failing for the right reason, the hard part is done, because you've had to think about the design of the code and you've had to think about what happens in this particular case. All you have to do now is write the code to actually make that happen. And surprisingly, this is like fill in the blanks, right? This is the difference between here's a method, you fill in the blanks. That's a lot easier problem type than starting from a blank page, write a method for X. Because in the second one, you have to think about what the design would be like. That's why when you get to that point in the TDD cycle, the hard part of the job is done. Now you've just got to write the code, and writing code is way easier than thinking about the design of the code, which is what this approach really makes you do. And so adding code to the app until the test passes green, that part's easy. And when you're done, because you've been incrementally adding code, look for places where you can sort of clean up some slop around the edges. And that is the red-green refactor cycle. A word about the kinds of tests that we use RSpec to write. Probably most of you until this class may only have ever looked at unit tests, which to me are testing a specific behavior within one method of one class. So in that case, if the method has collaborator classes or collaborator methods, we use seams to essentially control all of that behavior. But we also, like what we just did, was more like a functional test because it exercises behavior that crosses method and class boundaries. So for example, a controller flow has to involve the routing system. It's got to set up some params. And then at some point, you're going to verify that at the boundary where it calls the model, the right thing is happening there too. So we usually call those functional tests because they're testing a bunch of pieces that work together as opposed to just like one method in isolation. So I think of the request spec, which is basically what we were just working on, one round trip through the controller. To me, that's kind of a functional test. And the main difference for me between the kind of tests we write with Cucumber, a Cucumber scenario has many steps. And that implies that it's usually multiple HTTP interactions. It's multiple controller actions that are going to have to run. Here, what we were doing is one test exercises one controller action, one request. So for testing workflows, I think Cucumber is the way to go because you can outline the workflow as a sequence of steps within one session. For testing detailed code paths and behaviors within one request or within one model method, things like RSpec unit tests or RSpec functional tests are the way to go.